Hi guys, welcome to another one of Dollar Revision videos, and we are at number 23. Now in this video we are going to consider a topic of moments, and I had done in my YouTube channel and a little bit earlier an introductory video to the movement of a force. But summatively, when we consider the movement of a force, it is an application of a force where it causes a body to turn, that is, rotate in a clockwise or an anti-clockwise direction. So in its simplest terms, the movement of a force is where if you have a fixed point here and you apply the force, we consider a vertical force and a horizontal distance, and this force pulls the body in a clockwise direction. So of course, depending on where you consider your point of rotation, in this case, if I apply the force on the left hand side, it will cause my body to rotate in an anti-clockwise direction. So the premise of the moment of a force is in its usage of equilibrium. So if you have, in this case, a waiter holds a tray and the system is in equilibrium, you want to determine the unknown forces F and T, right? And then you'd want to determine how P is affected if you have a drink being moved closer to T. So you have basically a tray and you are highlighted with the different forces acting on it. So like the 7 newtons represents the weight of the tray. You then have a drink, which is 3 newtons, at some distance 0.5 from the point T. And at the points P and T, the tray becomes balanced by forces exerted on due to the hand on the tray. So when we take or apply moments, force by distance, we first have to consider a point at which the body is rotated. So I would have considered P. Now, whenever you consider a point about where the body is rotated, you do not consider any forces acting. Now, naturally, if I had not considered T as my point of rotation, I would have had a upward force acting, because you would have had some kind of reaction force between the finger and the tray. Nonetheless, when we consider here, you have the tray being balanced, we consider T to be the point of rotation. So about that point, you're going to have the tray rotating. Now each force is going to cause my tray to rotate with respect to T, because remember, T is a fixed point, it's not rotating, it's rigid, right? So my 7 Newton force will be pulled in a clockwise direction. My 3 Newton force is pulled in a clockwise direction, and my P is going to be pulled in a anti-clockwise rotation. So once you have identified, the first step is identifying your fixed point about which the body is rotated. It could be a pivot if in the question, or it could be any point where you have a force is acting. You just negate the effect of the force in this assumption, because the purpose of a point of rotation is that the body is rigid about that point. It is not free to move. So here you would have had 7 moving clockwise, 3 moving clockwise, and P moving anti-clockwise. So taking the moments about that point, you would have had 7 by the distance here to here, right? And that would actually be 0.26, right? Because this entire thing is 30 cm, this is 4, so this will be 26 cm or 0.26 meters. Then you would have had 3 multiplied by 0.5, correct, and that is P, and the distance of P to T would have been 4 cm or 0.04 meters. So working it down, you would have gotten 7 by 0.26 plus 3 by 0.5. So you'd have gotten 3.32 divided by 0.04. So this would have given you 83 newtons, right, when you worked it down. And then here, when you would have found you wanted to get P now. So P is your downward force, right? So therefore, P plus W plus the 3 newtons is equal to T. Right? So if you wanted to get T, it will be the sum of all of your downward forces. So it would have been P, which is 83 plus 7 plus 3, which would give you 93 newtons here. Okay? All right. So The last part says, what would happen to the magnitude of the force if the drink is moved closer to T? If the drink is moved closer to T, then you would have had a smaller clockwise movement and therefore a smaller anti-clockwise movement needed to balance it. Because if movement is forced by distance and you have decreased the distance between your drink and your pivot, then you are decreasing the movement. Okay, all right, so this is just a basic application question. So you could feel free to check out my YouTube channel for more upcoming videos on application of movements.